I feel so much better now. Okay. You guys can all see my drawing. Welcome back once again, guys. You guys can all see my drawing. The next session that we will be doing would be page 8A, as you can see on the workings out that I've sent through, and that refers to the staircase. And on the staircase, over here, on the staircase, there is quite a bit that we need to take in, hence me saying that I would leave the staircase over to today. The staircase, when looking at the staircase, you'll be concentrating on that section there, as well as that section there, for the staircase. So when we look at the staircase, number one that we need to understand is that the concrete that we have in the staircase will generally be of the same strength as that of the slab as well as the beam. I'll repeat that. The concrete strength will generally be the same for the staircase, the beam, and the slab. The reason for that is, for those of us who have worked on site and who have experienced when a slab is being cast and and there's a staircase, you will notice that all of those are cast in one go. We do not cast the one today and the other tomorrow. It will all be cast at the same time. Why is that? It is so that we have one unit, so that those beams, the slab, and the staircase forms one unit. And that is where we come on to that. Okay, so if we have a look at the staircase here, if you have a look at the staircase that we have in here, I will now start. We would notice that, and I'm going to circle this, that we have, let me just, I will now indicate where we will be starting from, and we will be starting from the excavation for the basis for this staircase. And if I look at the excavation of the basis base for the staircase, I would look at my drawing, and I would notice that when I look at, you can see where my pointer is. Can you all see where my pointer is? Right. And we can see that this part of the staircase, yeah, goes beyond that section there. Are you all with me? You can see that, right? So when I now look at that, I will now first and foremost have to start with the excavation for the base that we see in here. And where do we find this base? We find the stair base over here. So I can see that my natural ground level sits over there. That is the line of my natural ground level. But I will excavate for my base. But the size of my base, and this is what is important, is that the size of my base go through there, there, and there. That's the size of my base. But what is significant about that? I noticed that 150 millimeters of my base is under the ground. What does that mean? It means that when I excavate for my base, my excavation will only go how deep into the ground? 150 millimeters. All with me? Right. It goes 150 millimeters into the ground. I need to look at the width of my staircase. The width of my stair base, I get the dimension from there. And the dimension that I have there is a meter or 1,000 millimeters. Right? Now, I also noticed that the other dimension that I have is the width of that, and that is 600. So immediately it tells me that the three dimensions that I would have here would be a meter wide by 600 by 150 millimeters deep. You all have that. Okay. Thank you, guys. Please, I need for you, because this one you will have to talk to me all the time. Interrupt me if you do not understand what it is that I'm saying. So I've got those three dimensions. Now you know that when we excavate, we generally say backfilling to trenches and holes. But for today, we will now not be using backfilling. Why? Because whatever we take out will be replaced by concrete. So my description that I would have here is excavate impeccable material for stair base, not exceeding 2 meters deep, and set aside for backfill or cart away elsewhere measured. And then my next one would be extra over cart away as before. And my dimensions there, as I've illustrated them, would be meter, 5.6, 5.15. That is now for my stair base. Okay? But I still also have to measure risk of collapse. It's important that we measure risk of collapse no matter how shallow that excavation is. I will excavate. My risk of collapse will be risk of collapse to sides of trenches and holes not exceeding 1.5 meters deep from ground level. And my dimension that I have there is 3.2 meters by 0.15. Do we understand where I get the 3.2 meters from? Do we know where I get 3.2 meters from? Nobody understands. It will be 2 by meter and 2 by 600. Add that. That will be 2 meters plus 1 meter 200. It gives me a girth of 3 meter 200. You now understand where I get that from? It is, I look at my base, take my base from the top. That will be a meter. That will be 600. So I'm saying 2 times a meter and 2 times 600. You can see that. That is for my stair base. The risk of collapse with that, if I take a meter plus a meter is 2 meters plus 600 is 2 meters 600 plus 600 give me 3 meter 200. Well, happy with where I get that from now. 3.2 by 0.15. So what did I do? I just added all of those in order to ascertain the girth of my stair base. Happy with that? Okay. Well, happy with that. Right. So now I've got that. Now I need to fill that stair base with concrete. Need to fill that stair base with concrete. You can remember that I said that this concrete strength in my staircase would be the same as the concrete strength in my slab as in my beam. That being said, the concrete strength in my stair base, therefore, must also be the same as for my staircase as well as my beams and my slab. It will also be reinforced, meaning that it all forms one unit. I'm saying reinforced concrete 20 MPa 19mm stone in stair base. Then I now need to give this dimensions here. I'm saying that it is 0.6 by a meter, 0.34. Now, where on earth do you come on 0.34, sir? That's the question you're asking. Where do you come on 0.34? Remember that I said that my base is there, and there. You agree with me? That's my base. So, what do? I know that this section here is 150. How do you get to the depth of 0.34, sir? I've given you, in my description, I've given you waste calculation of 187.5. Now, where do I come on 187.5? Does anybody know where I come on 187.5? Anybody know where I come on 187.5? Can you see what I've circled there? You see what I've circled there? Looks like I'm the only one in this meeting today.
No, sir, I can see it, but for me, I don't see what the dimension is.
Okay, that dimension says 187.5. That dimension there shows 187.5. And what have I circled there where I've written 187.5? What have I circled there? The riser of the staircase, right?
Yes,
the
sir.
riser, right? Now,
Yes.
what is, you guys have done technology, what is one of the significant aspects of risers and threads? Is that they all should be equal in size, right? Why should they all be equal in size? They should all be equal in size so that when people ascend or descend the staircase, that they will not trip and fall, that there is a common height distance, whether it's horizontal or vertical, that they would be crossing. So if that circle dimension there is 187.5, it means that this height here that I have there should also be 187.5. Are you all with me?
Yes, sir.
Okay.
Yes, sir.
You can understand this. You can understand the sense or the rationale behind me having that as 187.5. You understand the rationale there?
Yes, sir.
Because each one of these now, that each one of those would now be 187.5, so that when you do ascend those stairs, that it will be equal as you go up. Not like the staircase that I ascended the other day where someone called me out to come and have a look at them, and the one was 200, the one was 180, the one was 220, and I nearly fell over because there was no consistency in ascending the staircase. So it's important that we still take the technology of all of this into account. What that says to me, if this here is 187.5, then that should also be 187.5. And then we add the 150 below the ground for my stair base. That then gives me 337.5 millimeters for the depth of my stair base. And I will then convert that to 0.34 as we're writing this in meters. All happy? All happy with the dimensions that I've used for the concrete in the stair base?
Yes, sir. Yes, sir.
Right. Okay. Now, as we see that the staircase, some of it sits below the ground, the stair base, some of it sits below the ground, and some of it sits above the ground. So the ones below the ground we know will keep the concrete in its place to the sides of the excavation, right? But those above the ground, how will we ensure that stays in its place? Those above the ground, we will have to do formwork to the sides of that stair base. We will have to do formwork to determine to ensure that the concrete remains in its rightful place. So we will say formwork to sides of stair base And I will then use the front as a meter wide, and I will say it is by 0.19. Where do I come on 0.19? 0.19 is 187.5 millimeters converted to meters will give me 0.19. The two sides, I will have 0.6, which is the width, by 0.19 by 2. You all see that. Then on the back, if we have a look at that, and I will just clear everything around what I've done here. We'll just clear everything around there. If we have a look at what we see over here, so if you have a look at what we see, and for this point here, that point that I have there, I have a look at this, and I need to determine what that height is from there to there, right? And when I look at this, it would appear as if this goes halfway. Now, my line went skew. It appears as if that goes halfway into the thread into my first thread. You see that? It appears as if it goes halfway into there. Okay, my line is now not too straight. So for me to ascertain what that height is there, I will take my front 187.5. We'll see that. And I will assume that the back there is halfway into my next riser, and I say times half, and I use that dimension there, and that gives me 281.25. So for my back rise, for my back formwork, I will then say it will be a meter by 0.28. It will be the formwork at the back of my staircase, my stair base. Right? And then I will also, now that I've done that, I now need to also measure the formwork to my risers. The formwork to my risers not exceeding 300 millimeters high, because the standard system tells us that for formwork to edges and risers not exceeding 300 millimeters high or wide will be measured in meters. So I will now say that it's a meter wide, and I will now count the number of risers that I have over here. You know what it told me? I will start from the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So the formwork to my edges and risers not exceeding 300 millimeters high will be 15 times a meter. We'll have that. Got that? You can see that. And all I'm doing is just going to go out here. Go out to show where the standard system speaks of. The standard system speaks of that. Just going to upload the standard system quickly again, guys. Standard system. It speaks to formwork. Here we see that on page 29, page 29, clause 14, edges, rises, ends and reveals not exceeding 300 millimeters high or wide will be measured in meters. That's what we've just measured over here. We measured in meters, and when I look at my drawing, I notice that I have 15 rises. You will also note that I have not included the bottom riser. Why is that? Anybody tell me why that is? Why I have not included that one? First one.
It's part of the base.
Part of the base. Part of the base, yes. Absolutely. It's part of the base, and that one was measured in meters squared. But for my edges and my rises, I measure those in meters. Right. So let me upload my drawing again. We are going great guns here. Thank you guys for cooperating with me. Right. So when I now look and I go to my look at my staircase, and I go further with my staircase, I would now look at the reinforced concrete that I need to now supply in my staircase. And the reinforced concrete will go in my staircase. If you can see, I will now be reinforced concrete now go there, there, and goes over there. Sorry, I've just drawn that roughly. But that is the concrete that will go into my staircase. Okay? And we'll say reinforced concrete 20 MPa 90 millimeter stone in stairs and landings. And I take that description straight from the standard system that says it will be in stairs and landings. Right? So, I now need to, first of all, determine what this length is all the way down there. What that length is going to be. How do I determine that length? You'll notice that I have a length of 4 meter 400 in there. But where do I come on that length of 4 meter 400? Where do I come on that length? If I have a look at, I need to determine, you can see that I have a parallelogram. Can you see the parallelogram there? You see the parallelogram that I've indicated there? Can you all see that?
Yes, sir, we can see.
Right. Now, what is the formula for the volume of that parallelogram? It'll be L times B times H, no? Is that correct? What is a parallelogram? Parallelogram is basically a rectangle that was pushed on a slant. Is that true?
Yeah.
Right. Now I need to determine what this length is here. I already have the width of that waist, which is given to us is 125 millimeters. 125 millimeters, but I now need to determine what the length is from there to there. Can I determine that? Can I calculate that? I can, because
Yes.
I have that dimension there of 3 meters. 3 meters is from there to the center of my beam. And if I look at where the center of that comes, it takes me to the front of that riser there. Right? And now to the front of that riser, and now I need to add my dimensions from there and there. Can you see what I'm doing? I now need to add, what's the width? 250. And I need to add another 250. You all see that? Because my center, see, I need to add that thread, and I need to add that thread, because that is where how far it goes. So there's 250 and 250 plus 3 meters. That gives me 3 meter 500. All with me on that? You all with me?
Yes, sir.
Right. So my horizontal or my adjacent is 3 meter 500. Right. Now I need to ascertain my opposite. Where's my opposite? I'm going to clear everything first. Again, you've got what I've just said here. Clear everything there. What is my opposite? Where will my opposite be determined from? I now need the height from there from there. Oh, let me draw it where it makes sense. I now need the opposite from there. From there to where? There. That's correct. I need that height. I need that height. In order for me to get that height, I will take my 3 meters that I have here. And my 3 meters is taken from the top of the slab, but I need to get to the bottom, so it will be 3 meters. I'll deduct my 150. I'll deduct the 150. Try and write a decent 0. Deduct my 150, which is my slab thickness. What else do I need to do? I also need to deduct 187.5. All with me?
Yes, sir.
Deduct my 187.5. Anything else I need to deduct? Is that it? That will then be, what does that give me? Yeah, it's 9 minus 7 gives me 2. 9 minus 3 gives me 6. Is that correct? 9 minus 2 gives me 7. Is that correct? No, not. That can, no ways that can be correct. It should be 6. Your calculators.
Yes, sir. 266. You're 2,662.5.
Yeah, that is 6. Yeah. Okay. So now I say 2662.5 square thereof plus 35. The square root of that. What does that give me? I don't even have a calculator with me. What does that give me?
It's 4,397.
4,397.6. 0.60 millimeters. But when I have to write that in meters, what will that be? 4.39 meters? No, is 4.4 meters. You now see how I arrive at that 4.4 that I indicate in my dimensions. You see that?
Yes, sir. Yes.
Right. So now you see that I'm taking my waist. Remember I said earlier that this dimension is what we will be working with first for the parallelogram that we had there. That was down there. So that will be 4.4 by the width of a meter by my 0.13, just for my waist. Okay? And then for each one of my stairs are now 0.25, 0.19, and by length of those are meter, and that is times half, times how many? Times 15. I say to you times 14. You agree with me? So why do you use 14 but for the rises you use 15 for the formwork? Is that a question you want to ask me?
Yes, sir.
Is that the question you want to ask me? Okay.
Yes, sir. No. Yes.
Let's see why. Right. You remember when I measured the rises, the formwork to the rises? Where did I start? I started over there. Right? You remember? I started there and I counted from there the 15 rises. You remember that, huh? Also remember that I had my line, those are not the straightest of lines. For my parallelogram that I had there. Can you see that my stairs, the stairs, actual stairs, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. You see that? You see that all this one here does, that first one, all that does is that forms a stair, yes, the riser to that very first stair, but it is not included in an actual stair that we see from there. Can you understand what I'm saying? I'm worried, there's silence now. I normally get a yes sir, but now I don't. I'm worried now because of. Did you get what I said now? I'm saying.
So, I don't understand.
Okay.
I really don't understand.
Okay. I'll show the rises again that I measured earlier. Right? The rises. Count them with me. Got those rises, right? You agree with those rises? Okay?
Yes, sir.
Right. Now, can you Remember this slab, this forms part of the slab that we had measured here. You see that, no? Now I'm going to show the individual triangles for each stair. Oh, I wish I could draw this thing straight. How many triangles do you see over here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Do you agree with me? You see 14 triangles there?
Yes, sir.
Right. You see 14 triangles. What did I leave out? I left out that one over there. See that? I left that one out. Why did I leave that one out? I left that one out because that forms part of the front of the landing. And it also has the same height as that of each and every riser that I have to measure. Does that make sense? Understand that?
Yes, it makes sense now. Thank you.
Okay, makes sense now. Right. So we have 15 rises, but 14 triangular sections of the stairs, and that is why I've measured this meter 0.25 by 0.19 times half because it's a triangle, and times 14 because I have 14 triangles over there. All good with that one. Right. Hello? Who wants to say something to me? I cannot see. I just hear that someone's trying to communicate with me. Who wanted to say something to me now? Mama Dinky, did you want to say something?
No, it's not me, sir.
No, not you. Okay. Right. But you do understand. Okay. If we now go with our formwork, and if we have a look at our formwork, and I'm just going to upload this again. It seems like some of us have serious issues with our connectivity. And if we have a look at the bottom here, remember that we had our stair base was measured there. You remember that? And our waist was measured there. Can you see that I have this little triangle at the back there? See that little triangle at the back? Right? You see that? We have not measured the concrete to that little triangle at the back there. You're all with me? So I will need to measure that triangle, but what do I have there? Because we said that it appears that we're going into half of that, I will take the half of that triangle, which will be 0.09. Right? It will be 0.09. And I will then need to now indicate and measure the concrete, and I will assume that angle is at 45 degrees, even though I know it's not at 45 degrees, but I'm assuming that because I have a 3 meter there and I have a 3 meter there, I'm assuming it's at 45 degrees, and if I assume that is half of 187.5, what is half of 187.5?
93.75.
93.75, right? So I will assume that is 93.75. So for my triangle, I will also assume that it's 93.7 and 93.75 what? 93.75 millimeters, right?
Yes, sir.
Millimeters. So now I will assume that my dimensions there would be a meter by 93.75 millimeters. How do I write 93.75 millimeters in meters? What will that be?
09.
0.09. As I said, I assume it's at 45 degrees, so it's 0.09, and that will be multiplied by half. Does that make sense? That is for that little triangle that I have colored in there now. That little triangle at the back there. You got that? Okay.
Sir, can you
Sure.
please repeat the dimensions, how you got to the last 0.09?
I am assuming because this is 3 meters and that is 3 meters, and I can make a note there, assume 45 degrees angle. So that if something's at 45 degrees, your opposite and your hypotenuse and opposite and adjacent would be the same dimensions, right? If something is at 45 degrees.
Okay.
You got that? Right. So that is my concrete to my staircase. Okay. Let me just clear this. Right. And I will now have to go through. And I now need to measure the formwork to my raking soffit of my stairs. And the formwork to my raking soffit of the stairs would be formwork to there. Right? But I do have that length, don't I have that length? No, I do not have that length. I had 4 meter 400 that I'd measured previously. But my raking soffit will not be 4 meter 400. And I will just blow up that little triangle at the back there. I'll blow up that little triangle at the back. Now remember that we said that this was 0.09. Agree with that? We said the other one was also 0.09. So I will say 0.09, the square thereof, plus 0.09, and the square thereof, and then the square root of that, and that should give me 0.13 for that dimension there, 0.13. Are you with me? You with me with what I've done there?
Yes, sir.
Okay, now what is the significance of this 0.13? Because I had previously calculated the length of that going down there as 4.4. Remember that? For my concrete, I measured 4.4 meters. Remember?
Yes, sir.
Yes, remember.
Yeah. But now the 4.4 takes me to there. But for the formwork of my raking soffit, I want it to only be to there. So I need to deduct that section there. And what is the length of that section? 0.13. Are you with me? .13. When I deduct that, I get 4.27. You now see where the dimensions come from that you see there that you've been wondering where does all of this come from? Make sense?
Yes, sir.
That makes right. So for the formwork to my raking soffit of stairs, it will be 4.27 multiplied by my width, which is a meter wide. Right. So now I've done that. And here comes the tricky part in what I will be looking at now. I now need to look at, and it's something that I trust that you would understand. You know, when we have a staircase, is that a staircase has steps. You agree with me? A staircase has steps. And we need to allow for these steps as follows. You see these steps here. I now need to measure formwork to the rake and stepped outer edge of the stair. As you can see me drawing the steps there. Formwork to the rake and stepped outer edge of stairs. And I need to indicate, oh, I did not write that. Formwork to raking and stepped outer edge of stairs. And I need to indicate what the extreme width height is of this raked formwork. I wish I was in front of you guys now with a board so I could illustrate this better. Writing with a mouse is not nice. I need to determine what the height is from there to there. And if I blow the staircase up, I need to determine what the height is from there to there. I already know that from there to there, it is 125 millimeters, right? I now need to, in my description, I need to indicate what that dimension, if I can call it X, is going to be. Just clear the clutter there. I need to determine what that dimension of X is going to be. And how do I do that? I see that I have a triangle there. Right? I have that triangle. I have this dimension here, and I have this dimension. That dimension is 250. And this dimension is 187.5. And if you look at my workings out, and I say that this here is theta. Theta there, over there. And I will say that the tan of theta will be equal to my opposite over my adjacent. Right. So it will be 187.5 over 250. That tells me that theta equals and if you say 187.5 divide 250, that gives me 0.75. Is that correct? So theta therefore equals, what does theta then equal? 36.87 degrees.
Yes, sir.
Okay? You happy with that? Right. Now I know that that theta there is 36.87 degrees. But what am I trying to determine? I'm trying to determine the length of from there to there. You with me? That deep red bold line that I'm drawing there. Happy with that? That's what I'm trying to determine, right? Because I'm trying to determine what the length is from there to there. I already have this length, but I'm trying to determine that length. So, what do? I have this. I do not have this. I'm trying to determine that. I have that as 250. I have my triangle over there. I can draw that triangle separately there. I would have right, and that is theta. I have that as 250, and I need this. This now becomes my opposite. You agree with me? So I now need to, I've got my theta here. I've got that, but I need this. So what is that? This is my opposite. I will then say that the sine of theta equals my opposite over 250. You agree with me? I say that the sine of 36.87 equals my opposite over 250. You're with me? And that tells me then that I can now take my 250 over to the other side. I take my 250 over to the other side, and I will then say that it is 250. I'm going to write this over here. 250 sine 36.87 equals opposite. Is that correct?
Yes,
Is
sir.
that correct? So if you calculate that, what does that give me? It tells me that my opposite equals 150. You agree with that? You guys are the math people. I'm not a math person. I'm just, so that's 150. So I now know that there is 150 and this is 125. Is that correct? So I say that my extreme would be 125 plus 150, and that says that my extreme width should be 275 millimeters. So where you see that description, formwork to raking and step out the edge of stairs, see that description? You should add a dimension. That's why I've left the space there. You should add the formwork to raking and step out the edge of stairs, extreme 275 millimeters extreme. That is what should be added in there. The contractor now knows that when they price that the extreme height of the raking and step outer edge of stairs must be 275 millimeters. We've determined that. Are you all with me now?
Yeah,
Are you all with me, ladies?
Yes, sir. And where do we add this 275?
The 275 would then go into your description. It will go into your description. You see where the description says formwork to raking and stepped outer edge of stairs?
Yes, sir.
We then add 275 millimeter extreme. Right? So we have now calculated what the extreme outside of my formwork should be. We've calculated that as that 275 millimeter. I'm sure all of this will be available on the drawing that I'm just taking out now, on the recording. Right. So, and my dimensions there for that would then be 4.27 times 2 because we have two sides to our staircase. Right? We have two sides to our staircase. Okay. Are there any other questions so far? Who's glad they came to class this morning? Glad you came to class this morning.
I'm glad I came, sir. I missed yesterday's.
You missed yesterday.
Yes, sir.
And yesterday was also an important one. Right. So, we've not done, that takes us to the end of the staircase. We've not measured the staircase. But this staircase needs to go in some. And this staircase needs to go where? We need to have that opening there. We need to have that opening there. That is created. So we now do the adjustments for the opening. Now the standard system tells us that no deductions shall be made for concrete, for openings for concrete not exceeding 0.1 meters cubed. In the same token, it says that no deductions shall be made for openings in formwork not exceeding 3 meters squared. Don't believe me? You can have a look in the standard system. It tells us that. So, what do we do first and foremost? You look and you'll see a note on my workings out that I said there. I've done a little collect for the opening. I said the volume of the opening there is 2.89 times 2 times 0.15. It gives me a volume of 0.87 cubic meters. Immediately it tells me it exceeds 0.1 meters cube, and I will deduct the concrete. Secondly, my area that I have is 2.89 by 2 meters, and it gives me an area of 5.78. And that means that yes, I will be deducting the formwork because it exceeds 3 meters squared. You with me on that one? Now, where do you get these dimensions, sir? Where do you get 2.89 from, and where do you get the 2 meter from? Right? When I look at my drawing, when I look at that opening there, I look at my section AA, and I notice that I have a meter and I have 3 meter. But if we have a look at where they go, they take me to the center of that beam and the center of that beam. You see that? Right. First out, I will then add those. That 3 meter plus the meter, it gives me 4 meter. Gives me 4 meter. Right? But I know that this beam is 220, and I need to be on the inside there. Right? But what am I do? What can I do? I will deduct, first and foremost, I'll deduct the meter. I'll deduct that meter, and that then leaves me with 3 meters. 3 meters, and then I know that this beam is 220. I need to be in the center. I'm in the center of that beam, so I multiply by half, and that gives me 110. So from there, I need to deduct 110 from that, and that gives me 0, 9, 8, 2. So my dimensions for my opening from here there is 2890. You got that? You with me? See that? I cannot see you. Remember, if I was in class, I'll see you shaking your head yes or no. Now I need for you to tell me yes or no, sir.
Yes, sir.
Okay. So you see where I get the 2890 from. Right. Now I turn this to the other side. I see that on this side I have 2210. Right? But the 2210 takes me to the center of the 200 beam and to the center of the 220 beam. So I now say 2210, and I deduct half of the 200 beam, which is 100. And I deduct half of the 220 beam, which is 110. and I deduct when I get there 2,000. You now see where I get my dimensions from. Because remember, this takes me to the center, and that also is at the center of that beam. Are you with me with my dimensions there? With me, guys?
Yes, sir.
Okay. Now you look at my adjustments for the openings. I say deduct the reinforced concrete 20 MPa 19 millimeter stone in slabs, beams, and inverted beams. I say multiply by 0.15 for my concrete and deduct the formwork to the soffit of the slab. And my dimensions that I've just determined here would be my 2.89 by 2 meters by my slab thickness of 150 millimeters. Yesterday, Mr. Brown, William asked me about this adjustments for the openings, and now today he's not here to see what I'm referring to. So I'm saying 2.89 times 2, and for the reinforced concrete will be times 0.15, and for the formwork it will only be the 2.89 times the 2. Okay, now I say formwork to my edges and rises not exceeding 300 millimeters high or wide. That is now for the edge of my landing. Or have I measured that already? Have I measured the edge of this landing already?
Yes.
Anybody, have I measured the edge of that landing already?
No, sir.
Have I not measured the edge of that landing? Where is this edge of the landing that I'm just measuring there? Where is the edge of the landing?
That color.
Measured there. The edge that I'm talking about here now, the one where I say formwork to edges and rises not exceeding
This is a class in
300
Okay.
is high or wide, refers to that section there. You with me? Because remember, I have already measured the edge of, this here, and that is, I'm going to just draw a jagged line there. I already measured that one there. Remember that when I measured the edges of the rises, so now I'm measuring that section from there to there, and formwork to edges and rises not exceeding 300 millimeters high, and that is for my landing, the edge of the slab. All with me? There. I then deduct formwork to the sides and soffits of my beams as before. This is where it becomes a little intricate, and I think that I need to actually clear the entire page before I get into that formwork to edges, deducting the formwork to the sides and soffits of stairs, and adding whatever We all know what an isolated beam is. We know what an isolated beam is. An isolated beam, if I say that you are isolated, if you are on an island all by yourself, would you be isolated? You'd be isolated, right? You guys? You'd be isolated if you are on an island all by yourself.
Yes, sir.
You get isolated, right? So you are cut off. Now the same thing here is an isolated beam, and if you look at this drawing here, you can see that this beam forms part of that slab. You see that? This beam forms part of that. You can see that, right? You see that? But you see what distinguishes this is the line of that slab runs through there, and the line of that slab that runs through there. If we, however, look at this beam here, you can see that that beam is not attached to anything. Can you see that? Apart from the beam on the side. That from there to there, it is not attached because we have an opening over there. Can you all see that? See that opening? And this here, this beam, this slab that runs through there, it tells me that this here is an isolated beam because there's no slab attached to that. So what do? Remember that we have already measured the sides and soffits of those beams there. Now the standard system, and I'm going to take you out and take you back to the standard system quickly. I'll take you to the standard system quickly. Upload the standard system that tells me we're dealing with formwork. Tells me here that formwork, now I'm dealing with formwork to slabs, beams, and stairs. That formwork to sides and soffits of isolated beams, prop of isolated beams below shall be given separately. That tells me that the beams that I've measured previously, I can now not leave that to be part of beams because I do have a section where there is an isolated beam. An isolated beam, guys and dolls, is where we have no slab attached to that specific section of beam. And you can see on the drawing, if I just go back into that here again, go back into my drawing again, you can see on this drawing that this section is not attached to any slab. Can you all see that? It's important that you confirm that you can see that. Guys, it's important. Can you see that? Can you not see that? Hello? Anybody with me? Everybody with me? I cannot hear.
Well, I'm just trying to understand, sir. That concrete below the landing. What is it?
I'm not with you. You say that below the landing.
Yes, that one.
This
I
over-
don't understand. Yes,
Okay.
that one, sir.
That one where my cursor is. Okay. You see that section there where the slab is. It is this beam. This part of the beam. No man. Not that. Okay. This part of the beam. This part of the beam there is attached to that slab, right? You can see that. But this from here to there, that beam is not attached to any slab. Can you see there the lines? The line that you see over there and on that same on the other side is not over here. You do not see that there. Can you see that?
Yes, sir.
Right. So with us having that, I'm trying to neaten this thing here. With us having that, it means that section, it means that this section here is now forms part, is isolated from the slab. That is isolated from the slab, and we call that an isolated beam. So I then say, deduct my formwork to the sides and soffits of my beam as before that I've measured previously. And I would then add formwork to sides and soffits of isolated beam, including propping up exceeding 1.5, not exceeding 3.5 meters high. Bearing level. So I've got my length of 2 meter 890. I've got the girth. The girth of that beam would be determined as follows. I have my 220 for the soffit of my beam, and I know that those beams, the beam at 3A, my apologies, 3A, if I look at my beam schedule, the beam schedule at 3A tells me it's a 300 deep, so I have 300 and another 300. I add all of those, that gives me 820. So I have my length of 2.89 multiplied by my girth of 0.82. So I deduct the formwork to the normal beams and I add the formwork to the isolated beam. Why do I keep them separated? It is because it is more expensive to do the formwork isolated beam because that will now not be attached to the slab. In the same vein, I will deduct my reinforced concrete 20 MPa 19mm stone in slabs, beams, and inverted beams. And I will add my reinforced concrete 20 MPa 19mm stone in isolated beam. My dimension 2.89, 5.22, 5.3. Again, the reason for them keeping it separated is because it is more difficult to now pour the concrete into that isolated section, as your waste would be more and it would be a little more costly. Are you with me?
Yes, sir.
Right. We've got that. And then, with us now having done opening this up, I now need to ensure that I have the formwork down there and formwork down there. And what formwork is that, sir? What formwork are you referring to? Remember that when I created this opening and I've already measured those beams, I now need to calculate the formwork from there to there, which is already have the dimension as 2.89, and I will have to multiply that by the I'll have to multiply that by the slab thickness. So it will be on this side. It will be, so it's 2.89 by 0.15 times 2 for that side and this side. And for then the other side, it'll be 2 meters by 0.15. You might ask me, but sir, why do you measure that? As well. I'm measuring that because if you recall, I deducted the girth, this full girth over there, and I added that back. So I add that first, and then I deduct it when I do my isolated beam. So I would say formwork to sides and soffits of beams as before, and that will include the 150 millimeter high over there, and 150 millimeter high over here, as well as 150 millimeter high on that side. And that, ladies and gentlemen, brings me to the end of my adjustment, as well as to the end of my concrete structure. Are there questions now? This is where you get to bombard me. No question.
Sir, can you please explain to me how you got that 0.82? Because I got a bit confused there. I don't understand.
Which one is that now?
The 0.82. Where you added
The 0.
that? Yes, sir.
The 0. This,
Yes, sir. Yes, sir.
this one over here.
Yes, sir.
Okay. You see what I've done? With my beam 3A, these are the dimensions for my beam 3A. The dimensions are 220 and 300. Now remember that we are creating that this is an isolated beam. That there's no slab on this side, there's no slab on that side. So what am I doing? I now need to deduct the formwork there. I say this 220 plus this 300 plus this 300. So the formwork for the isolated beam that I now, first of all, for my normal beam, I will have to deduct that formwork, and then add formwork to my isolated beam. You understand what I'm saying?
Yes, sir. I understand now.
But in the very last description, where I say formwork to sides and soffits of beams, because previously we had a slab that went through there. It was 150. The slab through there was 150. So I now added the 150 over there first and foremost before I could deduct all of this, and in order for me to add my formwork to my isolated beam. That is where I had added that. You look at the last description of formwork to sides and soffits of beams as before at 2.89 multiplied by the 0.15 times 2, and that referred to that one and the one on the other end on this side here. And I also had my 2 meter by 0.15 of that one there. But that 820 is taken up from the 300 here, the 300 there, and the 220. That makes sense?
Yes, sir.
Okay. Right. Okay, guys. I'm going to wish you well, but you are still free to send me a WhatsApp message or an email if you need further clarity what you need to do. Okay?
Thank you, sir.
Are there any other questions that anybody would still have to, that anybody still wants to ask me? Nothing. I started out with the ladies and I'm left with the ladies again. I feel so important. Guys have dropped. Okay, guys, enjoy your last day of 2020. And I trust that 2021 will be a better year for all of you. And I'll see you next week. Okay, but as I say, any queries you still need, you still have, you are more than welcome to still ask me anything that you would like for me to explain to you individually if that's the case. Okay?